Okay, welcome to fall 2023 class. You know, uh, all of you know me, so I really don't need to give my introduction to any of you. Our course is scheduled on Wednesday from 6 to 8:30. Sorry, 5:30 to 8:20. I'm just putting it like between 6 and 8:30. It can be 9, it can be 8, it can be 7, depends on how we are going throughout the course and the volume of the course load that we have so far. But I taught this course before in a different way, and this year I'm trying to teach it in a completely different way. Let's see how it goes. It's not going to be completely different way, but it's going to be like maybe 30 to 40% change than for how I used to teach it before, you know. So I tried to go over it like more descriptive. This year, I'm not trying to do that. This year I'm trying to make it like a little bit different. Amber will be the TA for this course. And when I talked to Amber told me that she didn't like so many presentations and asked me to cut off all the presentations. So basically, I will cut off some of them, but not all of them, because I believe that those presentations I usually try to keep in my course are good, at least from the self-learning perspective. So what is the best of learning? Do you know what is the best of learning something? Anyone?
Interactive, both ways.
Anything else? Any other idea?
Solving problems.
And
working around the problem on your own.
all of them are needed. Okay. Anything else? Okay. So the best idea to learn a course is to teach it a course. If you want to learn something, I recommend you to teach that course. That's how you learn the most, because when you are going to teach something, then you have a fear. So you have to break that fear. So to break that fear, you need to read a lot, learn a lot, and you have to go beyond all of your fears. So you need to learn from every fear, whatever the way you learn. You work with the problems, you don't work with the problems, you find out something to learn it, right? So I learned it in a very difficult way, but this is the best way of learning. So if you want to learn something, the best idea to learn it is to teach. And this is what I also want to do. So anytime I thought like I need to learn something, I usually try to offer a course on that. So that way I learned that and I grow. That's the secret of my learning. And it really works, I promise. If you do that at the end of the semester or at the end of the coursework, you will really feel like you learn a lot. Anyway, so the reason I'm saying this, the entire course I learned by myself. I never have taken any course or any class on this course, So when I started working on that, but I have some experience working on it and some good experience. And those good experience kind of helped me to broaden my thought process and all other things. So, you'll get that too. Anyway, so Is there any conflict if we change the course time to Tuesday 6 to 8:30 or 9? Anyone? No. I think the only conflict is Kelechi, but I already talked to him. So Kelechi is okay. So maybe I'll change the time to Tuesday from 6 to 8:30 or 6 to 9. And I just need to find out a room to teach the course, Still, I'll be teaching the same way as I'm teaching now. It's like you can also join through the Zoom. That is fine. But doing it on the Zoom allow me to record the course, and it's kind of super easy. And also, like some other students, they will be joining from using the Zoom anyway. But I thought like it might be better to go for in-person teaching for this one, because there will be like so many things we'll be discussing. Now, the course content about this course, this is one of the most broad, how do I say it? It's like, it's really broader content for this type of design, you need to have a very good understanding of all the different problems of the geodeck. For example, you need to understand the shear strength, you need to understand the consolidation, you need to understand the seepage, you need to understand the compaction, and you need to understand the slope stability. So you need to basically know everything, also maybe the unsaturated perspective. Saturated and unsaturated perspective. So whenever we are talking about the saturated and unsaturated perspective, it comes up with everything, So for this one, we really need to talk about different things. And in this course, I also try to implement some of the new things that I never covered before. For example, I want to integrate some of the methods that we used to use, or some of the methods that we developed in our lab. So I really wanted to integrate it in the coursework, and I believe that those are the things that are needed, and also needed by the funding agencies. For example, so every coursework we are supposed to do some improvement in the course, especially integrating the research results into the coursework. So this is what I'm going to do in it, I also have planned to invite 1 or 2 guest lectures, maybe 2, to have a an overall practical perspective of these problems. We can invite people from one person is in my mind is Willie MacArthur from the MDQ. He's the dam safety chief in Mississippi, and he usually give a presentation. So I would like to invite him on this course to give us a presentation. The other person I'm thinking about, he might be Mark, but some of you already have seen Mark, and I think some of you already have seen the presentation he may give. So basically, it might be someone else. I may invite someone from the Corps of Engineers to give us a presentation, So that's 2 I'm just thinking about. So the person might be Lenny Barfield from the Vicksburg district. So if it is Lenny Barfield, I think that would be great. So that's my 2 potential person to come and give us a presentation. If not, then I might invite anyone from MDOT, because there are like so many slope. It has 2 components in this course. Basically, this course should be broken down into 2 courses. The course number 1 should be only on the dam, and the second course should be on the landslide stabilization, investigation, and repair. This can be made like a 2 different course, because the topics are so broad. Anyway, so for the textbook, this is the course I recommend. This is the book I recommend you to collect. The one is here. You can, if you have a previous copy, that's fine. That's the third edition. That's the one we're gonna follow. But I think the second edition is also okay, because I don't think there is much difference between the second and third edition of this book, of the textbook. But this is a extremely good book in geotech, and I really recommend you to have this book. You know, this is one of the best book in geotech. The topics that we're gonna cover, you know, so the topics we're gonna cover in this course, the first thing is we're gonna talk about like some of the problems. We will talk about some case histories, some of the failures, and so on, so on, so on. But the basic coursework start with this, the seepage, you know. And I'm not very sure how much you have the understanding in terms of the seepage, but this course is all about seepage, you know. Our before the midterm, we will try to cover up to the seepage. And beside the seepage, I also cover a few other things, especially the compaction. So in this course, in the previous version, I didn't cover the compaction, but in this version, I really wanted to integrate the compaction as well. Basically, the different compaction effort, what are the requirement with compaction, what actually happened, what is the connectivity between the compaction versus the consolidation, you know, consolidation, and all other things. So these are the things that we're gonna cover. And then we will have some other components, which is the slope stability analysis. Then we will have like some combination of the seepage and slope stability analysis, you know. So the seepage and the slope stability analysis, and I guarantee that this is the major component that we will try to cover in this course, which will be really great, which is one is the seepage analysis and then the transient seepage analysis. Now the seepage and the transient, like a steady state seepage versus the transient seepage condition, we'll be discussing. And I think there are not many academic course that covers this content, you know. Most of the course try to cover only the seepage or maybe the only steady state condition of the seepage. But I really wanted to go for the transient condition and what really happens in terms of the transient condition, what are the things that we can go over. And I'll also try to include some of the case studies related to that and how it can be integrated in the design of it. The other components that we can maybe have in this course is the construction control, compaction. I already mentioned the compaction, the settlement, and the case studies, you know. The settlement and the case studies, basically this component I'll try to cover in the next class, you know. This is the component I'll try to cover in the next class, and I will give you an assignment, and the assignment will be targeted that you have to select a problem like a failure, and then you have to present the failure in a 15-minute presentation in the next class as a group. So there will be like 3 presentations. Each of the presentation will be 15 minutes. So we just covered like half of the class with that presentation. And the following part of the course, we will be covering the entire thing. Give me a moment. Anyway, so for the presentation in the next class, there are going to be like three presentations. We have 9 students in this course, so each group will have like 3, you know. And then with it, the 3 students, you're gonna have to make a presentation on a on a case study, I'll assign that in and I'll put that in Canvas on that. Okay. All right. So that's the way we save some time in the course and we move on. And in terms of the grading, we'll have homework. We have a review paper presentation. That's going to be 10 marks. So the review paper presentations are basically the one I'm gonna cover. I'm gonna put in this in the next class. That's one, and I'm gonna add maybe 2 more. You know, in this semester we're gonna have like 3 paper presentation, review paper presentation as the group. In the previous years, I used to give it like the entire and each person present something. But to save the time, I'm trying to cut it short, you know, and make it like a group presentation. The basic idea is so we discuss at least 3 papers or maybe 9 papers, you know, in it. So we cover that content as well. So we can go over the course materials and we can talk about like what is really happening in it. So that will be covering targeting the failures and all other things. Sorry for the interruption. Anyway, so are you getting any noise on the back? No noise? Okay, because it's a noise canceling headphone. So it should cut the noise. But if you're getting the noise, let me know. Okay. So I have other options. Are you getting the noise now? No noise? Okay, very good. I like it. So okay, so the next one is there's gonna be one design project and there's gonna be another design project. So basically 2 design projects. The first one will be on the CPT analysis. The second one will be on the slope stability analysis. 2 things. We'll have a midterm, we'll have a final. That's it. And a term paper. So many things. There might be an option, I may combine these 2. You know, there might be an option, I may combine these 2 together. If I combine these 2, that might be better, you know. But usually the design project one, I usually give like a hands-on calculation on the C page on everything, because we're gonna go for some of the manuals, and each of the manuals we will try to cover it from there, you know. So I need to say it's like how it's going to work there. That's pretty much it. Do you have any question on the syllabus? Oh, like my other semesters, I can assign the term paper and presentation earlier. It will be only the term paper, no presentation. It'll be only the term paper. You need to submit the term paper. So I can submit the term paper. Usually my term papers are, I assign 5 papers. You need to review 5 papers and you need to write 1 paper out of it. Those are the term papers. So, and this is required for the ABET activity dictation. So I always follow that, you know. So we always need to, we have like 3 learning outcomes and this is required in 1 learning outcome. So the term paper is covered by 1 learning outcome and the design projects are another learning outcome. So basically these 2 learning outcome we need to follow according to the university rules. All right.
Right. Dr. Khan, just you gonna give us the term paper earlier, or you're gonna leave them?
I'll try to I really wanted to give it earlier. And even for the term paper, you know, at the end of the semester, there are like too much pressure, you know. So what we can do is we can set an early date of the term paper submission. Maybe within a month, within the first month. How about that? Submitting the term
yeah.
paper within
First month will be the best thing, I think. Less pressure.
less pressure. Omar is here.
Yeah, I've been here for 10 minutes.
Okay, good.
I have a question also for the projects. I was looking at the syllabus earlier, and so most of the projects, or basically the projects, will be limit equilibrium, right? It's not going to be finite element.
It's gonna be finite element. The second one,
Because I was
the
looking,
slope is.
there is like slide 7 and slope W in the syllabus.
Okay, the slide 7 and slope W, but slope W, you know, the slide 7 has a finite element in it, which is the
for the
seepage
seep.
analysis. Your seepage
Yeah.
analysis is always the finite element.
Yeah, even in the Geo-Studio, it's slope or CW is also a finite element.
Yes. Now this semester we are trying to cover the Geo-Studio, Omar,
Okay.
not the rock science, because we are in a process to buy the CW, buy the entire Geo-Studio, you know, and I'm planning to cover that instead of the slide.
We are doing the other way. We are now getting rock science instead of using Geo-Studio.
You are getting the rock science, so do you think they're like using the rock science would be better choice? We can
I
do
think
that.
they are keeping both, but we are working on slope. I mean Geo-Studio for a long time, and they just getting the license for rock science because it has, like, you know, you can do the piles, the L pile, and all those stuff. There is
RS file.
something
Yes.
for rocks and stuff. So they are getting the whole license. So we're getting both, but they are now encouraging us to download it and start working with it. And we are gonna get a training probably next month or something.
Okay.
Rock science.
Well, we can cover that. It all depends on how you wanna play. We have everything. I can also go for the plexus if you would like. I can also go for the rock science, or I can go for the Geo-Studio. But I already told Lambert that it might be better idea to integrate the Geo-Studio, because the core is
I'm
using
fine
the
with all of
Geo-Studio.
I'm fine with all of them.
Okay, let's think about that. Maybe it's possible to give the both demonstration. That might be a good idea, you know.
It's almost similar once you.
Yeah, it's almost similar, but on the file, like if we go for the repair of it, you know, if you wanna go for a repair of it, then I always can integrate some of the things. I always like to give a problem which is very difficult to solve, and so you need to go with different iteration. So whenever you play with it, you learn it. That's the basic of learning, right? So unless you just learn how to use the software and learn it, it doesn't help doing one problem. You need to run at least 10, 15, 20, 30 trials. So every trial you run, you learn something.
Yeah.
You know? So there are different problems that I used before, many different problems. One of the problem might be there might be like a slope and it has a seepage issue. With the seepage issue, it's also creating some landslides. Now you need to take care of the seepage, so you need to come up with a design to take care of the seepage, and then also you need to do something to take care of the slope stability. So it's a pretty complex problem with you need to take care of almost everything. And then there is a catch. If you want, you can also play it in not from the steady state perspective, but from the transient analysis perspective. And basically, I am offering this course for that perspective because I really want you to give the understanding for the LeFi project. And that's why I'm teaching this course. Otherwise, I don't have any interest to teach this course. I just offered this course like sometime last year, right? In last spring. Usually, I don't offer any course within 1 year time frame. I usually repeat the course in 2 year time frame. So I can have a diverse course. But I'm repeating this just because I thought like for the LEPI it's needed, you know. That's my primary thought, to cover everything.
I mean, that would be great if we have that problem combined, seepage with a slope stability.
With transient condition.
Yeah.
And maybe unsaturated condition too.
Drawdown conditions.
Rapid drawdown, well, rapid drawdown I always cover. So we'll have the drawdown condition. It will be there, no matter what, you know. And this is one of the most favorite course to teach, you know, because this is a complex course. This is a complex course material. So the more complex it is, is more interesting to teach, you know.
Yeah.
Anyway, so any other questions so far? No. All right. So all the course material is already been uploaded in Canvas, and you should be able to access it. So this course has like several manuals, and I already uploaded all the manuals in the Canvas. So you can go there and you can check that. I just copied it from the last semester, so from the last year's course. So basically, it has most of the course material from the last course. But if you want, you can download all of it. It might also have some videos from the last semester, but I'm gonna remove that later on. So, but all the materials that I had, I'm gonna keep it. And this introductory course document is already in the Canvas, so you can look into it. Now, one single question: what do you understand by the dam? Dam. What is the purpose of the dam? Any idea?
Water retention.
Water retention. That's the number one job, right?
Yep.
And why we need the dam?
Irrigation, hydropower,
Irrigation, hydropower, flood control,
commercial.
creating a reservoir, right?
Yeah.
Audrey, can you say something?
Flood control. And for
Flood
storage
control.
system, water storage system.
Okay,
Okay.
yes. One of the one major use of the dam is in US is creating the reservoir and the for the water supply. You know, there are so many reservoirs in US. Both are, I think, part of the flood control system as well as the reservoir, creating the reservoir, right?
Yeah.
So basically that's one. Now, so how many types of the dam we may have? Is it like it's all earth dam, or there might be different type of the dam?
No, there's different, like there's the concrete dams, like they call it arc dams. I don't, blocking dams. There are
Okay,
different types of dams. There's a lot, actually.
there was a lot. Yes. So basically, when we try to have a dam or when we build a dam, what are the things that we really need to look at or need to cover? Any idea? Before I start even I start the course, I don't have anything. I'm just asking to know is like how far you know.
Like in general, why we want to build the dam, or like what we need to do before build the dam?
Why we need the dam? I think we already talked about that. Now, the question is how big we can build a dam.
So it depends on the soil condition, the seismic activity of the area,
Mhm.
the water flow, probably the
Okay.
precipitation.
Mhm.
There's a lot of factors we can look at.
Okay, but
But the
what is the
soil
major?
type and the soil type, I would say, and yeah, if it's seismically active or not, I would say it's very important to know. And
Sure.
how big is the dam we are looking at?
So how big it might be?
Can be huge dam, like the ones in California. They are very big dam.
How big?
I don't have any information, to be honest. But there is like very, very big dams around the
Throw
world.
me a number. Anyone. Throw me a number. How big? What is the height? Height of a dam.
I think the largest one is Three Gorges Dam. I'm not sure actually.
What is the height of the Three Gorges Dam?
I don't know. I have to Google it.
Can you Google it? I don't have it in my slide. So can you Google it?
The tallest one is 305 meters.
305 meters,
Yeah, like 1,000 feet.
like 1,000 feet, 10-story building, or 100-story building, right?
100. Yeah.
100-story building. So the one, the Ross Barnett Reservoir, the dam we have in Mississippi, or in our backyard. So, do you know the height of that dam?
Maybe 100 feet or no, less. Yeah, maybe 60, 70 feet, something like this. At least from the spillway side. I'm not sure from inside.
The
What
water
is the
level
height of
is
it?
around 3 meters, if I'm not wrong.
What is the height of the dam?
It's not much big, around 3 meters.
No, 3 meters is too short. It's higher than that.
It's higher than that? Okay, it says the bottom elevation. I'm looking at the documentation Mark gave us. So the elevation is 308 and the bottom elevation is
Yeah, the water level stays around 3 meters, yeah. So
yeah, it says like the height one side is 20 feet and maybe another 10 feet. So 30 feet. Yeah, this is what I thought. That's only 30 feet, 10 meters. You know, that's it. So, and that's an embankment dam, right?
Yeah.
So embankment is a very interesting thing. And so far, I think like we have projects in all type of the embankment, right? How many type of the embankment there might be?
Levees, highways,
Levees, highways,
earth dams,
earth dam,
railroads, probably.
railroads. Yes, that's it.
Four types.
Four types, right? Each of them has a different appeal or different use. You get my point?
Yeah.
Each of them has a different use, and each of them has a different type of the load. Each of the embankment. So highway embankment, what is the load?
The traffic load, dynamic.
The traffic load. But that traffic load is not too big, right?
Yeah.
Is like there are 18-wheelers, a series of 18-wheelers. But if you compare it with the railroad, you know, then it's a way different type of the loading, isn't it?
Yeah.
And I feel like the most challenging one is to build the railroad, the most challenging one. And there are many cases those railroads are built at a certain time, at a certain way, that it really doesn't consider all the geotechnics of it. So because of that, the railroads are not very well built. So if you look at like China, if you look at if you look at China, if you look at Japan, and if you look at the US, and if you look at like Bangladesh, then do you know what is the major difference in the railroad construction?
Probably I would say, soil types, weather, different geology here and there, so it's different. Not sure how they design it in China, Japan, and Bangladesh, and even in the US, I don't have that much.
Have an idea? Okay, does US has a high-speed train?
No,
Does Bangladesh, or let's say India, has a high-speed train?
not sure.
Not
No.
sure. But both China and Japan has it. Right? So
Yeah.
those high-speed trains, well, do you know the speed of those trains?
I don't have any idea.
Those are close to like 400 kilometers per hour or so.
Yeah,
You know?
maglev train speed is about 400 kilometers per hour.
Yeah, close to 400 kilometers per hour, close to that. Now, this type of train cannot tolerate one thing.
Friction.
No. Friction is fine. Friction is okay. But it cannot tolerate one thing in the embankment. What is that?
Carbs.
What?
Carbs.
For what?
Carbs. No, carbs is okay. You just need to have a like big curve, the turn, right?
Carbs
Because
on
you
the
can
board.
add the super elevation. You always can add super elevation to counterbalance the force, right? That's how
It doesn't allow settlement, uneven
it doesn't
settlement,
allow settlement.
maybe.
It doesn't allow the settlement. As long as you have a settlement there, you cannot build it. And that is the biggest challenge in US, to have a high-speed train. That's the biggest barrier. Because there are many railroads, those are built before the geotechnical engineering become popular, you know? So those are not very well built. Now, if you want to build it like with a high-speed train, they always have the settlement, you know? And whenever there is a settlement, that creates the challenges. If you look at Bangladesh, do you know the train speed in Bangladesh?
Highest would be like 80 to 80 kilometer per hour, maybe highest.
That's the highest. Do you know why?
Maybe.
Far side of the settlements.
It's because of the settlement, because those are really soft subgrade. The subgrade condition is really soft. So it's going to have a settlement, you know, an even settlement. So you cannot speed up. Anyway, so then the earth dam. So does the settlement is a critical issue in the dam? Good. Okay. So here are some, the Three Gorges Dam is not an earth dam. Three Gorges Dam is the concrete dam, you know. But there are like some biggest earth dam. Earth dam can be as much as 100 meters. That's the highest. You cannot build beyond 100 meters. If you need to build beyond 100 meters, then you have to go for concrete dam. You really cannot build earth dam. But there are like different types of the dam. So the hydraulic earth-fill dam, one is located in the Missouri River, so which is the Fort Peg Dam, Montana. I just try to find out like some of the biggest earth dam. This is one of them, you know. Now there are some other considerations need to look at. Another one is the rock-fill dam. Now, if you have the rock-fill dam, the height goes up. If you just have the earth material like dirt in it or the soil type material, the height is close to 1 meter. But if you make it like rock fill material, or you can have some stabilization with the cement, you know, then the stability goes up and the strength goes up too. You know, another one is the San Luis Dam in California. I think this is the one Omar was talking about, right? Omar, this is one of the biggest dam in California.
Yeah.
Then we have the Garrison Dam. Okay, so which organization take care of the dam?
Different organizations. There is
Not the Corps of Engineers, right?
we take care of some of them, not all of them. But there are like different agencies. FEMA take care of
Okay,
federal,
so
I think.
which agency take care of that? Do you know the name of that agency? Which take care of, who are responsible for the dams in United States?
ASTO,
What?
ASTO,
ATSO, no,
Association of
ATSO.
Dam Safety something. I forgot the whole name.
Officials, that's a professional organization. They're not like a government mandated organization.
Well, it says here 80% of the dams are covered by the Corps of Engineers.
What?
80% of the dams are covered by the Corps of Engineers.
80% of, okay. I'm right now I am blackmailed. So what happens? My son just came to me and asking me to buy games, and he know that since I'm in a meeting, I'll just do whatever he asks me to do. So I just paid $10 to buy a game. Another $10. So I already paid $20 to teach this course. Okay.
Thank you.
The name is USBR. Thank you. Sorry. Anyway, now the basic question. So is the major job of the dam? Do you know the major job of the dam is the retain water, right? And how about it happens like this? Have you seen a photo like this? Does it happen?
Yeah, happened
It
2011,
happened.
2019.
How many places in 2019 we have this type of photo?
I think we had some up in Missouri, Kentucky. Also, we have some in New Orleans.
New Orleans is all during the Katrina, right?
Yeah, New Orleans got, I mean, actually, it got a lot. But the ones in New Orleans are designed to be overtopped, so they usually don't have breaches. But the ones up north, little bit, they had some. And I would say Missouri and Kentucky. But 2011.
But this is the photo right here is not a overtopping failure. It's a breach.
Yeah, that's a breach.
Right? Now, usually, do you know the failure is like the failure criteria for the dam? What happens during the failure? Do you know what is the number one cause of the dam failure?
Seepage.
Seepage, absolutely seepage. And when there is seepage, there is something happens. Do you know the terminology of that? Whenever there is a seepage, something happens within the dam.
inside the dam?
Yeah, or levee.
Because I know there is like, not sure. I don't want to say wrong things.
Do you know? It's called internal erosion, piping.
Oh yeah.
Whenever there is a seepage, it eventually create a piping, you know. And there is a classical failure. It's one of the major dam failure in US. So that is the Teton Dam failure. Teton Dam, you know. And Teton Dam failure is being considered as one of the most devastating dam failures in the history of Earth dam. You know, it's a massive dam and it failed because of the piping. So there are some videos in YouTube. So your next class presentation, I really want you to cover the Teton Dam. That is one. Another dam I would like to consider is the Oroville Dam, which is the most recent dam failure, right? And the third one, I still need to find out. I need to decide which one. There are like several other dams too. But this is these two dams. The other one is the Oroville Dam. You know, there are some literature available on the Oroville Dam failure too. There might be another one we can talk about, which is a dam failure in Mississippi. You know, so you guys can also review that and make a presentation. So I'll break it down into three teams, and each of the team need to make a presentation on that. Each of the failures. So we'll cover like different type of the failures. Before I jump into the topic of that dam, I have a question. What is the difference between the dam and levees versus levees?
Levies are for roads. I'm sorry.
Levees are for roads. Okay. Any other idea?
The levees,
So levees,
levees are just for flood control. They are not always having water on or retaining water on any of the sides. The dam is the main object of having a dam is just to retain water basically, and then the other things. So it's basically having water on one side all the time, but the levee will have temporary raise in the water levels, and then it will go down at some point. It will not
Okay.
be loaded like for, I would say, permanently. It will not be loaded permanently.
Any other idea? Think more.
Sure.
You're right. Any other idea? Any other thoughts from anyone else? Difference between dams and levees? If you want to mathematically present the major difference between the dams and levees, how do you present it?
okay, for me,
Both-
I think the levees we are designed to protect the land side, not but the dams to save, uh, like to collect or save the water, like like a storage of water. But the
Okay.
levee
Yes.
is going to be on the land side to protect uh, the soil, like from the failure or something like that. Beside the rivers beside, or for flood control.
Okay. Yes. Anything else?
I'm not sure
That's
about that.
Go ahead.
Okay.
Yes.
Is it like one have two-way or both way cities or something? One have water in both ways, both sides.
No, it cannot have both of the system cannot have water on both sides. If you have water on both sides, then it looks like this, the photo right here. It means it's not working. Both of them are built to retain water, you know. But the purpose is different. Dam is basically built to store water, and levee is built to protect you from flood. That's the basic need. But in terms of the applicability, the design principle is also different because of the difference in the applicability. So basically, you know, if we look at the use of it, so let's say if it's a dam, you have a certain height of water with the time, it's a flat line for dam. So you have a constant height of water most of the time. It may have some variations, like it may go up and down like this, you know, depends on the rainfall, depends on the use and all of it, you know. But usually the dams are built like this. This is dam with almost a constant height of water. Or levees, are built for this. You know, it has a certain hydrograph, it comes for a certain time, and then it goes away. So now you can build the levees in different ways. You can build it like this, you can build it like this, you know. So basically you can create it like overtopping conditions if you build it like this with a certain hydrograph, or you can build it with your expected height of the flooding, and you can try to build it like you'll allow no overtopping, right? That depends on the design. But since it doesn't hold water for a long time, you can play with the design, you know. So there is a major difference between these two. So the major difference is it always remains in steady state condition. Levees always remain in transient condition. You know, so basically the difference between the dam and levee is between the steady state versus the transient condition. Both will have seepage, both will have different components, but there are the majority of the levee that is being built in US doesn't have a steady state condition at all, or even being exposed to the maximum capacity. You know, it was exposed to maybe 80 to 90% of its full capacity it is designed for. But now in terms of the steady state condition and transient condition, there is one thing. If you have a long-term flooding, remember the flooding called long-term. So if your flood hydrograph is like this, you know, then it's going to create a steady state condition. And that creates a lot of challenges on the levee whenever you have a situation like this, you know. But if your time duration is short for a certain time, then this is always a transient condition problem. What is the meaning of transient condition?
It changes over time.
Changes over time, okay? And it's an intermittent condition, not a permanent condition, right? It's not a permanent condition. A statistic condition is basically a permanent condition. So it's always there. Okay. Okay, so we'll start the dam. We'll go for it. So let's take a 5-10 minutes break. Okay, let me give you a break to come back, and then we'll start the discussion of the art dam. I'll finish the entire lecture notes, but I'll just go over it. So I'm not gonna go into very details of it, because I'm just trying to give you an idea of what we're gonna cover, overall. But this is basically all the components that we need to cover in the entire course. So my job is not to cover everything by today. Yeah, this is the Teton dam. I need to check if it works. This is the failure of the Teton dam. And so we'll just cover that, and then we will continue it in the next class too, because that's the understanding the failure mechanism is the most important thing for the design. Well, when you have a good understanding of how the failure happens, then you can always build a good structure, because you know the basics. So right now it's 7. So what time you wanna come back?
7:10.
7:10? Okay. Okay, so 7:10, and I'm pausing the recording. So please remind me when I start the class to start the recording. Okay?
Okay.
Okay, thank you. It's in recording. Okay, we're all good. Can you see my screen?
Yes.
Okay, awesome. So basically, I need to talk about the component of that dam. So first of all, what we have in our dam, we have an embankment, right? So here's the embankment in it. Then what we need beside the embankment?
Spillway.
Spillway, which is a control structure, right?
Yeah.
Control structure. Do you know why we need a control structure in the dam?
Control the outflow of the water from the dam and the water level.
Do you need a control structure in the levee?
No,
Why not?
because it depends actually. We might need some, but it's because it's just temporary loaded. We don't need control structure, but sometimes they add like the relief wells to reduce the pressure from the water side and
Okay.
reduce the water level, to like instead of having the seepage problems and the piping. So it's kind of controlled, where's the water's gonna flow and where's the outlet and how much water might flow.
Okay. There is another difference between the dam and levee, and that is also very crucial to understand. So basically, when we have a dam, let's say we have a water body, it says river or channel, Now we want to create a reservoir. So let's say we plan to make a dam. So this is our dam. Then what's gonna happen? And because of we create the dam, it will create a certain reservoir capacity right here. Depends on the geology, geomorphology of the site. It's gonna create a certain reservoir in it. But later on, what is happening? We are trying to cut off a flow to create a dam or to create a reservoir, right? So now what happens is, let's say we create the reservoir. So let's say we build the dam. First, the water level goes up, and it creates this steady state condition. Now you also have a continuous flow of water, right? So whatever the water flow is coming, Q, that needs to be drain out. So the Q in is equal to Q out. You have a constant height, right? So the Q in is greater than Q out, then what's gonna happen?
Catastrophic failure eventually.
Catastrophic failure eventually. So Q in is greater than Q out. It means the height goes up, and maybe it's going to be onto the freeboard, and then maybe it's gonna have overtopping and a catastrophic failure, right? How about the Q in is less than Q out?
The dam
Then-
is going to lose its stored water.
So the volume will go down, right? The height of the dam will go down. So that's in the dam. But the purpose of the levee is different. The levee is not built to create a cutoff of the flow, right? Levee is built to protect the overtopping on the side of the river bank. So basically, let's say we have, let's say this is the river. So we build levee here, we build levee here. That's how we do it, right? So our flow of water is going this way. You know, if I want to build a dam right here, so we are trying to build a dam like this. This is the dam, perpendicular to the flow line in most of the cases, right? Levee is parallel to the flow line. That's another major difference between the dam and levee. So that's why within the dam, we must have a control structure. So that control structure is known as the spillway. You know, some spillway are like overtopping types, some spillway are like just using the pipes. You know, you can have like say several pipes, and within the pipes you can create the height or the control structure. Now in the hydropower, what we need to do?
We need to increase the height of the water.
Okay, let's say this is the dam. So let's say this is the dam. And we have the water height here. Okay. But we want to create a hydropower, right? Means what? We want to use the potential energy of the water. And so the potential energy, if we want to use that, then where is the highest potential energy we're going to get?
Top of the dam.
If the upstream and downstream has a huge height difference,
Okay, so at what point we'll have the highest energy? Highest potential energy.
lowest water level, like the
Lowest
downstream
water level.
at the dam.
So somewhere right here, right? Isn't it? So let's say if we create a pipe or piping system, then what's going to happen? Water will come out with a really high power, high velocity, right? So if the water is coming out really high velocity, and now if you created the dynamo inside, so that dynamo will have some propeller in it, and it will just run through it. So it will just try to rotate the fan, right? So that's how it creates the hydropower. So in this case, that spillway becomes the control structure, and that is the source of your energy. You know, but in those type of cases, they also need to have some other spillways, because let's say something is wrong, or they need to have like some kind of maintenance in it, need to cut it or need to stop it. So they also need some kind of control structure. So they always have another set of spillway, and they can have like a primary spillway or a secondary emergency spillway, you know? So the primary spillway versus the secondary spillway. Secondary spillway is designed in a way, in case your primary spillway is not good enough or is not working, so you always have a backup plan. So this is your backup plan. You know? So, and what is the objective of this spillway?
To protect the dam from failure.
Well,
Okay.
the water, yeah, I just,
Drain the water, right? Whenever is needed, we can drain out the water. That's the objective of this spillway. And then we need to have several other things. One thing is the abutment. You know, the side at the abutment. In the earth dam, abutments are not that important. But for the concrete dam, abutments are really important. You know? So let me go back and let me ask you a question here. Embankment dam, 305 feet, right? So 305 feet is the dam. So this is a dam in California, right? Embankment dam, completely made with soil or earth type of materials. So, and the objective is to hold the water. But can you calculate the water pressure at the bottom of the dam? 305 feet, right?
Yeah, 305 times 62.4.
So this is 305 feet. Or let's say it's 305. Let's say 5 feet is our freeboard. But if it's full at that range, it can be 305. So for the design purpose, I think it's better to consider 305. So let's go with 305. So the pressure at this point, water pressure at this point is gamma WH, right?
Yeah.
So gamma W is 62.4. So 62.4 multiplied by 304.
720.
How much?
You counted 305?
Yes.
19,032.
19,032
Yeah.
PSF, right?
Yeah.
Okay, so if we create the pressure diagram, at the bottom is 19,032 PSF, right? At the bottom. What is the height? 305. So what is the force per linear feet? The force per linear feet. Remember the length. I'm just considering a unit feet.
220,000. No.
How you are calculating it?
Times half times h. So it's going to become h squared times.
Okay, so this is gonna be 0.5 multiplied by h is 305 multiplied by 19,032. 19,032, right? That's the pressure P is equal to
2,900,000.
2,900,000. 2,900,000. 200.
Yeah, no, 290.
290. Okay.
2380.
290, 2380 pound, right?
Yeah.
So in kip, so is 2902 kip per feet, right? So let's say 2,900 kip per feet. Kip per feet, remember the load. You know, that's the load. Kip per 2,900 kip per linear feet is working here, you know. So what we need to create, the sliding resistance, right? It's a retaining wall concept. We are trying to retain the water. So first of all, we need to maintain all the criteria of retention. Means it should be
Sliding.
and
Yeah.
bearing capacity.
Thank
So
you.
So it has to recover the overtopping, sliding, and the bearing capacity. The reason I'm showing you the numbers is because the importance of the abutment. You know, now it's an embankment dam. You can distribute the load, right, in a large area, and you can make a massive, like a mountain. If you make a mountain, the idea is you are just trying to build a mountain. You know, the mountain is good enough with its self-weight, so the self-weight will counterbalance all the forces coming from the water, right? That's the basic. That's the stability first. You have to make it stable. So if you want to make it stable, it should be good enough to take that load, no matter what, right?
Yeah.
Otherwise, you build it, the first time you fill it with water, it's all gone. It's just a complete washout, right? Look at the load. It's a massive load. No other structure needs to have or needs to sustain that amount of load. No civil engineering structure carry that amount of load. You know?
Yeah.
Next. So basically, when we are building an embankment dam, we are trying to create that amount of resistance from the self-weight of the material, right? So, and that self-weight should be counterbalance the lateral force coming from the water. Are we doing this calculation right? Can you please double check?
Yeah, 62.4 times 0.5 times 305 times 0.5. Yeah. Divided by 1,000. 2,900 kip per feet, yeah.
Right?
Mhm.
So can you feel the load? I want you to feel the load,
It's too much.
you know? So when we try to build a building foundation, how much load we talk about? Per column?
1,500? No, this.
50, 60 keep.
100 kip, 200 kip, maybe 500 kip. It's a massive structure. That's maybe 2,900 kip per column, maybe. You know, if it's like 100 straight structure per column, the load we get is maybe 2,900 kip. So if you're making a big bridge, that bridge supposed to take like per pier is 2,900 kip. You get my point?
Yeah.
And this is the load per linear feet. So you have, what is the length of it? Let's go and check. Where is it? This one, right? What is the length of it? They don't have the length? Yes. Can you check the length by any chance? Google it. The length of the embankment dam. Usually the length is more than few thousand feet.
9 miles.
9 miles?
Yeah.
Okay.
North to south, yeah, at its longest point and 5 miles wide. That's
The
a huge-
9. So you get my point? So how much load is stored there? How many atom bombs? The power of it.
It can wipe the whole.
It can wipe the whole California, right?
Yeah.
All you need to do is just to create a small hole at the bottom of it, right? That will create piping, that will create the internal washout, and it's gone. Can you feel it? the amount of load it has. Good. So basically, this is what we need to do. That's why I was talking about, like, this is one of the most complex understanding you need to have. You need to have a very clear understanding of every piece of it, you know? And in this type of structure, you really need the quality control. A significant amount of quality control is needed. And you need to look at every piece of it. But if you go back and look at the abutment of it, you know, this abutment, for those dams, the abutment is not important because you're building it with the self-weight. But if it's a concrete dam, the height is even like tripled. Do you know the height of the Hoover Dam? Can you check the height of the Hoover Dam?
Over them,
Yes.
I think it's 100 meters.
726.
726 feet.
Yeah,
Yep, that's the Google says.
Okay, so can we calculate the water pressure in the Hoover Dam at the lowest point?
726 times
0.5 into 726 square multiplied by 62.4. Right?
Yeah.
Sorry, it's not readable.
Y
Let me
square.
clean it. Yeah, the pressure is half multiplied by H is gamma 62.4 multiplied by H square. So it's 724 square, right?
That's
Divided by 1000.
16,044, 444. Let's say 16,500 cubes.
60.
16, yeah,
Keep per linear feet. Got it? And how does it looks like? It's a slender, it's a beam, right?
yeah.
It's just a concrete, it's just a concrete dam. So how you can build a concrete dam like that, taking that amount of load? You're muted.
It's some kind of retaining wall, I guess.
Yeah, it's a retaining wall. Basically, dam is a retaining wall, right? But look at the load of the retaining wall. And look at the amount of load it has. It's unbelievable. So if you want to create a, let's say it's a pile supported structure, then the basic is, let me open a new page. Create PDF, new PDF, blank, create PDF. Okay. So let's say it's a Hoover Dam. So basically this is our foundation soil. On top we have the water. So let's say this is the water table. And then we are trying to create a concrete dam, right? Not massive, like this. But how the foundation is gonna be? So the foundation, like a pile, something like this. So what is the height of it? 724, right? Feet. The basic thumb rule is whatever the
You need double that.
unsupported length, you need to double the whatever the free length, you need to double it. So if this is L, you need 2L. That's the thumb rule, right?
Yeah.
Only for
So
dams. Only for dams.
only for dams.
No, for everything.
Yeah, it's like not for dam. It's like for a lateral loaded pile. Whenever you have a lateral loaded pile, so your unsupported length is this. If it is L, then at least you need 2L in it. So your total length is 3L. That's the thumb rule, you know. If you wanted to create a short long pile action, you know, long pile action means you need to create a cantilever beam. That's it, you know. So the whole thing will act like a support, and the top will behave like a cantilever. So what is the length we need? If it's a 724 feet, let's say 725. So this is gonna be like 1450, right?
Yeah.
Gonna be 1450 feet. Can we dig 1450 feet?
Maybe.
Maybe.
Depends.
Yeah, we need the tunnel boring machine, you know, instead of our auger, we need a tunnel boring machine, but we need to go vertically.
Oh, it's too much.
And then we have to design a special tunnel boring machine because look at the earth pressure at 1450 feet. You know, the amount of earth pressure at 1450 feet is gonna be unbelievably high, right? So the hoop stress is going to create on top of the tunnel boring machine. The TBM is not going to sustain. You get my point? So think it's theoretically it's possible. Say it again.
Can you repeat? Actually, we are disconnected.
Oh, sorry. So it's basically I'm saying like if we need to build a tunnel boring machine, then the amount of hoop stress at this point is gonna be unbelievably high, you know, because water pressure unit weight is 62.4, right? What is the unit weight of soil? 120, 120, 130. So it's almost double, right? And then your depth is double too, right? So the amount of hoop stress is trying to put on the TBM is make it impossible to build, you know. But the Hoover Dam is there. Hoover Dam is considered as one of the engineering marvel. And it's considered one of the engineering marvel because of the amount of load it takes. Same as the three gorgeous dam, you know. So what happened in the Hoover Dam? How they build it? Any idea? What is the shape of the Hoover Dam?
Has the arc shape.
It's an arch shape, right?
Mhm.
So the Hoover Dam is built on the Colorado River, right?
Yeah.
And what are the side walls of the Hoover Dam?
Mountains or rocks.
Mountains, right? So what happens in the Hoover Dam? Hoover Dam is built in between two mountains, built like this. So this is your Hoover Dam.
So this distributes the load to the mountains.
This distributes the load to the mountain, nothing else. It doesn't have a foundation at all. You know, so it get all the resistance from the side wall. You know, it get all the resistance from the side wall. And that's the abutment, you know. So whenever you have a concrete dam, your abutments are very, very crucial. Otherwise, you cannot even build it, you know. You know, see a similar Similar one? I think there is a one here. Yeah, this one, similar. This is the abutment. Right here. It transferred the load on the site. Because if your height goes up, it's really difficult to make it thick, So then you have to transfer the load and distribute the load. So if you have the rock on the site, that's a very good place to build it. But you cannot build it in Mississippi, much bigger dam. Do you know why?
It's all clay. There's no rocks.
There's no rocks. It's flat plain. It's a flat plain, right? Especially think about the Mississippi Delta. If it's a delta, it's a flat. It's all flat, right? And if it is all flat, it's very difficult to build an dam. So now the countries, they usually used to have all the rough terrains or the mountains. They usually try to consider that it's rocky area, so they don't have the blessings, right? But if you're looking at the current market, the current energy market, all the rocks or all the mountains becomes your big resource, right? Now you can use that and you can harvest the energy. So if you can harvest the energy, you always can solve a big problem, right? Anyway. So basically, another component of it is the foundation soil, Another component is the foundation soil because the foundation soil controls the other things. Let's say we want to build something, but think about the amount of load the earth dam itself have, because how much load we are trying to resist? 2,900 kip, right here, where we did the calculation. 2,900 kip, right? Is right here, 2,900 kip. So basically, if we need to resist 2,900 kip for the sliding resistance, we need to have at least with a 3 factor of safety. So which means the dam itself can resist close to 900 kip per feet, right? With a sliding factor of safety 3. So it's supposed to resist 900 kip per feet. Let's consider a frictional resistance of 0.4 or 0.3. So do you know who gives the friction? The friction angle, right, of the soil. So the friction angle of the soil is basically, what is that number? 10 phi, right? Sigma 10 phi. So that's the frictional resistance. So if we are trying to have 900 kip per linear feet, then, and we have only a phi, then we have to find out how much weight we need to give, to create that certain amount of frictional resistance. The question also gives something, but we need to have per linear feet 9,000 kip. So we really need to build a massive structure just to resist the sliding resistance. Forget all other things, forget slope stability, forget all other things. You just need to make it stable to take the load. It's coming from the water. So basically, if you can get involved in a dam project or a dam construction project, it will change your career, right? Because of the massive decision makings, massive construction, massive challenges every single day you will have. The amount of earthwork needed to build a dam and your margin of error. What should be your margin of error to build a dam?
0.
0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0 Otherwise, what's gonna happen?
You're gonna kill a lot of people.
Catastrophe.
It's a catastrophe. A dam failure is always a catastrophe. There is no other way, you know. A dam failure is always a catastrophe. So I always fear to stay on the downstream side of any dam. You know, I don't want to live in the downstream side of any dam. After working with the dam and levee, you know. But it's not necessarily it's always true. So we should also believe on the other engineer's design, and that should have the enough safety. So the basic requirements of the dams, or the construction of the dams, these are the basics. I never give like a question answer type of question, but I think I should have these 4 points and ask everyone to write it, you know. But remember it no matter what. So your embankment, foundation, and abutment must be stable at all conditions. The word is must. You know, seepage through the embankment, foundation, and abutment must be collected and controlled. You know, the third one is the freeboard. Do you know what is this freeboard? What is freeboard?
The height above the water level from the structure.
From this structure. So we cannot fill it like at the up to the top, right? We need to have like some clearance. So freeboard is the clearance. And the spill and outlet capacity must be sufficient to prevent overtopping. Now, do you know the major cause of the dam failures?
Overtopping.
Yes, that's not seepage. The major cause of the dam failure is the overtopping. Number 1. Number 2 is seepage. Number 3 is landslide. You know. Okay, so what is the best way to build the dam? How we should build the dam?
Get your calculation right and know your soil conditions.
Okay, very good. So that's why the site investigation for the dam construction is extremely crucial. You know, it is recommended to cut a trench along the foundation soil and go through layer by layer, you know, and look at if you have like any potential hotspot or seepage within the foundation soil, right? Because the dam itself, we are going to build, that's a control structure, right? We control the field, isn't it?
Yeah.
But the foundation soil, we don't control, right? So who made the foundation soil?
Sedimentation.
There are many geologic processes, right? And it is not a man-made structure. So it's not a controlled structure, it's an uncontrolled structure, right? But we are going to use that to control the water flow. So the same amount of pressure will try to flow through the soil too. What is the pressure? This is the amount of pressure, water pressure, right? So that water pressure will try to pass through everything, right? Just think about that amount of water pressure you have in a pipe. You get my point? That amount of water pressure is passing through the pipe. And that's an unbelievable water pressure. And that water pressure will try to pass through everywhere, you know, the soil, the foundation, any leakage, any weak point it found, it will create a internal erosion. Because when water passes through the soil, what's going to happen? pressured water. You know, whenever there is a pressured water, the pressured water trying to break the soil skeleton. You know, it just has the internal structure of the soil. It's trying to break the internal structure of the soil, and at one point it's able to break it if your pressure is much higher, right? So it will create internal erosion, and then eventually it goes for the piping and all of it, you know. So what are the type of the failures we may have within the dam?
So it's the overtapping or the seepage, I mean, or piping, slides, maybe sliding. That's the most common.
Overtopping, sliding,
Breach,
breach,
piping,
piping, and all other things. Okay. So now the basic thing is, you know, if you have the drainage layer, first of all, let's say we have, what is it? Let's say we have something. Let's say this is the dam, right? We have a water table right here. So this is the water table. Whenever there is a water table, what's going to happen?
Pressure,
It will have a seepage line, right? Like this, eventually, when it reaches to the steady state condition. So it reaches to the steady state condition means we'll have a water table like this, right? So when there is a water and there is seepage, what's going to happen in our downstream slope?
power,
Whenever we have the water table, the downstream slope will be in a vulnerable condition, right? And then it will also has the potential of having the wet area right here, because water table is ending right here. So you will always see that this area is wet, you know, because that's the end of your seepage line. You're never gonna see it like water is coming out, but you'll see it wet. Means there is some release of the water, right? Which means your seepage line is ending here. And it's continuous, water is coming out. So if water is coming out, eventually you're gonna have some kind of erosion, right? Some internal erosions is going to happen. That comes for free whenever you have a flow of water, right? So what is the best idea to protect it?
Cut off the seepage line.
Cut off the seepage line. So how we can cut off the seepage line?
have like impervious material in the core of the levee or the dam.
So we need to build some kind of impervious structure. The first thing that we need to do, no matter what, is we need to catch the seepage water, and then we need to take the water out in a control structure. You know, we cannot let the seepage go uncontrolled. You know, seepage must be controlled, which means we need to have some kind of, let's say, some kind of internal drain, you know, in it. If you build a drain in it, then what's gonna happen? Now the seepage will come and then it will flow like this, right? So if it flows like this, we are solving two problems. First, the stability of the downstream slope is already been taken care of. right? And the second is the seepage will be controlled, so we are cutting off the chances of the piping, right? But sometimes we don't need to build it up to this height. We also can build it like this. We also can build it something like this, which means we can have it up to here. It's up to here. And we can just have a drainage blanket up to this layer, you know? If you have a drainage blanket, then it will end up to here, the water, the seepage line. Do you know why the seepage will end here, not goes all the way?
This is the shortest way for water.
The shortest way of water. So why there has to be shortest way?
Less pressure.
Why water will go through the shortest way?
Suction.
Due to capillary action.
Okay. Why water has to go through the shortest way?
Because of suction.
No, because it tends to go from the highest pressure to the lowest pressure. So if it's created as a drain to take the water, the pressure will be low over there. So it will just move that way.
Okay. Any other idea? It's a philosophical question. Now can you answer it?
People tend to go the easy way. The water.
Exactly. Water always travel the least resistance method. Water always follow this. That's the winning formula for water. You know? Now let's say if the water finds a sand seam right here, it really doesn't matter how many internal drainage blanket you add. What will just go this way?
Yeah.
You know? Even though this is the lowest pressure, because water only follow the least resistance method. Two things always follow this. One is water. What is the other? Other one.
People. People.
No, people depends. People depends. It's a
Electricity.
electricity, exactly. Two things follow exactly the same route. Water and electricity. Both of them follow the least resistance. You know? But I also try to follow this whenever possible. This is my starting point for anything. Whenever I see something, the basic response for me is the least resistance method. So how I can solve the problem without doing anything, you know? If it doesn't work, then I start creating more resistance. But unless I have to provide the resistance, I always try to be fluid. And these things really works. You know, in most of the cases. Not for every people, but in most of the cases it works. So this is basically a philosophical question. How water flows. So always try to remember that whenever you are doing a seepage analysis, you know. Whenever you are doing a seepage analysis, always try to follow that, because there might be conditions that there are other situations. So there might be some issues where you may have some sand seams or some other problems, and but there are no analytical method for a special case. You know, so the analytical method for the special case you always need to find out. Correct? So those are really tricky. Really tricky. Those are really tricky things. Anyway, so I don't expect you to get that at the very beginning, but it takes some time to follow, you know. And my objective again for this course is to build the feelings in you, so you can feel how it's going to flow, you know. And you need to have these feelings without doing any single calculation. The calculations are going to give you the justification. Your calculation is right. But this is, your feelings is basically comes with your engineering judgment, you know. And our objective for this course is to develop that engineering judgment. All right. Okay. So the way I'm moving, I'm gonna need three lectures to finish it instead of one. But there are many other methods. So it's like these are the conditions whenever your foundation is impervious. But if you have a pervious foundation, then you always need to do something. If these are the impervious foundation, you know, then you need to do something. But if this is a pervious foundation, then you also need to do something, you know. Basically, you need to create a cutoff system. So there are different ways of creating the cutoff system. Some of the ways are cost effective, some of the ways are not cost effective, but you need to do something to take care of that, you know. But the main thing is you have to understand the basics and what is really going to happen, and you have to make your call based on that. So there are some pervious foundation. So if there is a pervious foundation, you basically need to create a cutoff system, no matter what, you know. And you need to do some seepage analysis to make your decisions. Then there is a rock fill dam. Rock fill dam is basically you are just if you are trying to build it, where I do it right here, right? So let's say we have a dam, earth dam. Earth dam always have a certain slope, right? We cannot go beyond that slope because our angle of friction, phi, controls everything, right? We have some C, but basically the phi controls everything. So if the phi controls everything, we need to have a certain side slope. Basically, we say 3-to-1, 2-to-1. It's very aggressive to build a 2-to-1 slope for a hard time, you know. It's better to make it like 3-to-1 or maybe 4-to-1 slope. But if we don't have enough space, or if the cost goes up, you know, if the cost goes up, maybe it's not a good idea to build something with this method. You know, can you hear me?
Yes.
So in that case, we need to build something which will change our change the system. So in this case, instead of the earth fill dam, we can build a rock fill dam, you know. That will help us to solve many problems. So if we have a rock fill dam, that's a complete set of design. And in this case, the rock fill dam is better. Basically, the rock fill dam design is one of the best way of designing the dam, you know. The only challenge is we don't get rock everywhere. So that's the challenge. So you can have the zoned dam. That's the basic idea. So whenever you have the zoned dam, you can take care of all the different pieces, you know. Because you have, let's say, slope stability problem, you can use a better material where you have a high chance of slope stability. You have a seepage problem, then you can use the different materials to control the seepage, you know, at different levels. You can also add like many other control structure, like the filter zones, the drainage blanket, drainage system, all of it, and that will trap the water, control the control everything, and you can have a very good sustainable system in place. The selection of our dam comes with many different things that depends on the topography, geology. Those are very important component. The material available is also very important, especially what is the fill material. You're in certain area where you don't have the fill. Let's say maybe you have more clay, you don't have sand or silt, then your cost of the construction will be significantly high. If you need to haul more than 20, 30, 50 miles, the hauling distance is one of the major criteria to select the materials, So that's why any project needs the feasibility study to find out like what are the components needed, and if there are like enough resource to have all those supplies. There are other component is the environment and the economic component. I think there is another component which is missing here. That is the social component. The social component is also very important nowadays, because it depends on how people live their life and how building a structure or control structure is going to change the lifestyle of the community. Because ultimately, as an engineer, our job is to improve the life, right? And help the society. So for any structure or selection of any structure, this is a major component too. Because with the social component, there is another thing comes with it is a job creation. So infrastructure is a major field to create job. So that is also something we need to look at. I think let's end here today. So we can talk about the overtopping and the failures, but I think it would be better to talk about the failures after we have the case study presentation. So in for your next class, I will give 3 dams. I'll post it in Canvas by maybe tomorrow. I just need to find out 3 different papers, 3 best papers. I know there is a failure on the Oroville Dam, and I think there are some very good papers on the Oroville Dam failure. There are also papers available on the Teton Dam failure. So these 2, I'm just thinking about the 3rd one. There is a dam failure in Mississippi. We can also give that one. But I have a question like how we can divide it the group. We don't have
just 6 students, right?
And Said is not here. They're out of town. That's why they're not here. So they'll be here next week. So how are we gonna distribute the group?
How many students in the class?
9. So 9 students, 3 group.
3
You
groups.
want to make your own group, or you want me to assign the group?
I'm fine with anything.
Give me an idea. I really need it.
Dr. Hen, you assign the group.
I assign the group. Okay. So I'll assign the group. So this group will be continued throughout the semester. Okay. So I'll make a group, but if you have any specific choice, let me know.
I can make a group now.
You wanna make the group now?
Let's vote on that. I can be me, Odrik, and Abdul Rahim if they want to make a group.
Okay.
And that's fine for me. It's all right.
Yeah, it's fine for me too.
It's fine for you too. Okay.
But you choose the topic for us.
And choose the topic. Okay, so it's a strong group, so and to think about what topic I should assign. So maybe you go with the Teton Dam.
Okay. So what we are presenting, just why the failure happened, the design of the dam, or just
Yes,
overview
the
or
overall perspective. It's a case study, why the failure happened, what things went wrong, how they could have done things right, so that this catastrophe not happen, and what is the learning from this. So, and how it affected the policy and all other things, you know, the engineering practice. Every failure teaches something. I think the third one I should give is the levee failures in Katrina, all the levee breach in Katrina. So one is the Teton Dam, the second one is the Orville Dam, and the third one is the levee breach in Katrina during the time of Katrina in New Orleans.
we
There are,
can talk about the levee breaches.
huh?
We can talk about the levee breaches.
You wanna talk about the levee breaches?
I think I got resources for that.
Okay, you have better resources for that. Okay, so that's a good idea, because our objective is to learn. You know, I am picking these three topics because I really want you guys to have some background on this first. You know, what are the things happens and what went wrong. Every failure makes some big changes in terms of the policy. Each of the failure. So we just need to find out like what are the things went wrong. Do you know who is the owner of the Orville Dam? Orville Dam failure is, I think, is the latest failure, right?
I can check.
I believe so. So let me stop my share and let me try to see if I can find out the Orville Dam failure.
Happened in 2017. It is managed by.
Yeah, for this one, you are open to see everything, like every type of the videos, every type of the analytics, everything that you found, you know. So let's say if I go back to the, where is it? Let me share. Yes. Can you see it? That's the Orville Dam failure. So there are like many other things. It's like there are many different videos on that failures, you know. There are photos and videos. Finding of the Orville Dam spillway forensic investigation. There are like several others. So look into it, read it, find out all the videos. You can show the videos too in your presentation, you know. So APSO is a very good resource for that, you know, in terms of the Orville Dam failures. There are also others on the Teton Dam failure, you know. Teton Dam failure. So this is the Teton Dam failure, you know. This is the case study. They also have it right here. So this failure also has like some videos in it. What are the things went wrong? How to do these things right, and so on, so on. There are so many things, you know, right here. So the Teton Dam failure is here. The learnings and all these things of the Teton Dam failure. What happens in the Teton Dam? Brief narrative of the dam failure, you know. So there are like several videos. So this is the basic. This is the major failure because of the piping, you know. That's the piping failure. Orville is a overtopping failure, and it's an external erosion. So it has overtopping, then it has a failure. I know there are many teams that try to build something on that, you know. So that's the Orville Dam failure, and the third one, there's a levee breach. Breach Katrina, you know. So there are several things you can find, and Omar has access to all of it, right?
Yeah. I can get all of it.
So Omar can get all of it. So we'll have the discussions is like what are the things that went wrong. And so your presentation should be 15 to 20 minutes. So the first half of the class will have that. And then the second half of the class will go over and talk about other is like all the failure types, you know, because the first thing is we need to understand the failure criteria. That's the starting point for any design. So that's why I'm assigning these 3 case study. So which is the group number 2? It's very difficult for you guys to pick the group. Okay. Okay, so I'll do a lottery, and then within the lottery, I'll pick the group. Okay, so it comes with a lottery, but I wanted to distribute it too. You know, so I want a teamwork. You know, so the teamwork is very important here. So anyway, so that's pretty much it. I think we're not too late. Yeah, 8:25. So we can end here for the first class, right? And okay.
Dr. Khan, can I give you a call after the class, after the lecture?
You can stay. We can have a talk. Okay.
Okay.
Yeah, right now.
Thank you.
I think,
Thank you so much, Dr. Khan.
thank you.
Have a good night.
You too. Thank
Bye.
you. We're going to stop share and I need to stop recording. Where is the recording?